The topic of this lecture is example of canonical form of second order PDE. We'll cover these three examples. Example number 1, example number 2, example number 3. So let us see the first example. Reduce the PDE, this is the PDE, and it's into canonical form and solve it. So that is the problem. So the given PDE is this. From here, in every question, we'll find the value of R, S, and T. So what is the value of R? R is the coefficient of this. What is S? S is the coefficient of del 2z by del x del y. And T is the coefficient of del 2z by del y square. That will be same, fixed in every such questions. Then we'll find the value of S square minus 4RT. That also will do in all questions. So when we'll put the values from here, we get the value 0. So as we are getting the value 0, the PD is called the parabolic. In place of 0, if sometimes the value come, it is greater than 0, this value if it come greater than 0, then we call the equation is hyperbolic. And if the value comes less than 0, then we call the value the equation elliptic. So these are the classification into three form. Then we'll find the value of R lambda square plus S lambda plus T. That also will do in all such types of question by putting the values from here, and we get this expression. And when we'll solve this expression, it is very easy. You will get the value of lambda is equal to x by y. From this, we find solve this differential equation by putting the value of lambda. We get this, and from this we are getting this value. And when we'll do the integration, we'll simply find it is x square by 2 plus y square by 2 is equal to, say, some constant by 2, say some constant c by 2, and taking the 2 to cancel, so it will be x square plus y square is equal to constant. So this value, first value, we'll take as a value of psi, and then we'll find the value of eta. That also will do in all questions. The eta should be such that it should be independent of psi. That is, it should not be multiple of psi. So let us take eta is equal to x square minus y square. Note that how we have taken eta over here. Now, as the value of xi and eta is this, so we'll first of all find value of xi x, zx, zy. That also will do in all such question. And these two expressions are standard. You can keep this in memory. And when we'll put these values, the values of xi and eta and its derivative in these expressions, we'll get these two expressions. And then we'll find the value of zxx, that is partial derivative with respect to x of zx, that is given by this. So again, if you keep this in your memory, that you can write this from this expression directly, so there is a no problem. Whenever such types of question comes, you can write this expression directly. So no need to do all this calculation. If you can memorize this, you can put this value. And from here, when we'll find derivatives, second derivatives, as in the case of this is first derivative, this is second derivatives, all these values when you'll put, you'll get finally this expression. How this is coming, you can see from here. Note that what is xi x, that will be 2x. What is xi y, that will be 2y. What is xi xx, that will be 2. What is xi yy, if it is required, then it will be also equal to 2. So I am writing this is xi yy is same. Similarly, you can find eta x, that is 2x, and eta y, that will be simply minus 2y, and you can find the further derivative also. Now, as in the case of zxx, you can write for zyy this expression directly, this expression, and when we'll put the values from here and its derivative, we'll get this expression. Now first of all, just see the compare this two expression. Here in place of x, all x, if we replace x with y, we are getting this expression. So there is some similarity, that is changing x to y, we are getting this expression. So these two values we have found, zxx and zyy. Then we'll find the value of zxy. Again, that is the standard form of solving all this. So again, if you can keep in memory, you can directly write this expression. This is nothing but z xi x y, z eta x eta y, and this expression, and this. So this will also be same in such types of problems. So keep this in memory. Then again, the putting value of xi x and xi y and its derivative, you will find this expression. So all these three expression we have found, these values will put in our original equation, that is the value of this and this we have value found from here, and the value of zxx and zyy we have already found from this, that is zxx is this and zyy is this. We have already found this. So putting all these values over here in this expression, and when we'll solve this, you will simply get this. Many of the expression will be cancelled, you will get this. And from this, easily we conclude that z eta is equal to 0. Now, what this implies that del 2z by del eta square is equal to 0. And when we'll find its first derivative, you will find the value of del z by del eta. By finding the first integration, you will find a constant which is depending on xi. And when you'll find the second integration, you will find that it is a depending on xi eta plus b, a function of xi. So this we have obtained over here. And when we'll put the value of xi and eta over here, we get this expression. How we find the value of xi and eta? Because we have already known that the value of xi is equal to this and eta is equal to this. When you will solve this for x square, you will simply find that it is x square is equal to x square is equal to, sorry, the beta value of xi is equal to this and value of eta is equal to this and value of xi is equal to this. You can simply find, so which is the required solution in this case. Now let us see the second example. Here also we have to reduce this equation into canonical form. Again, as I explained, we'll find the value of r, s and t. The r is coefficient of this, that is 1. S is 0 because z, x, y term is missing. It is not there. So the value of s is equal to 0 and the value of t is coefficient of this that is minus x square. And again, as we have seen in the last case, we'll evaluate this. That will be 4x square. It is greater than 0. So it is hyperbolic in this case. Again, we'll solve this equation. R lambda square plus s n lambda plus t is become this expression by putting the values from here. So this gives lambda is equal to plus minus x. So lambda 1 is this, lambda 2 is this. And accordingly, we solve this expression. And when we will solve this, let us take dy by dx is equal to, how to solve this, dy by dx plus x is equal to 0. This you can simply solve as a dy is equal to minus x dx. And by finding the integration, you will find y is equal to minus x square by 2 plus c. And taking this expression over here, you will get this first expression. Similarly, in place of this, if it start with minus, you will get this expression. So these two values we have found. Because two values we have found and these are the independent solutions, so we take the value of psi is equal to the first and eta is equal to the second. Same way as we have seen in the last example, we'll find the value of zx and zy, that is the standard as I told in last slide also. and putting the values from here and its derivative, we get this expression. Similarly, in case of zxx, this is the standard expression, and by putting the values and its derivative, you get this expression. Similarly, in zyy, you will get this expression, that is standard, and putting the values and its derivative, will get this value. And we are not finding here zxy. Why we are not finding zxy? Because it is missing from here. It is not here. So no need to calculate the value of this. Now putting all these values in this expression, our expression will become this expression by putting the values of zxx and zyy from here. And when we'll simply simplify this whole expression becomes this expression, and from here z eta xi eta is equal to this, and by putting the value of x square, that will be this. How to find the value of x square? That you can find by solving this too. When you solve this, you will simply find x square is equal to xi minus eta. So that will put value over here, and by this way, this is converted into canonical form. Now let us quickly see this third example. So again, this is the expression. Here again, we'll find the value of r, that is the coefficient of this, the value of s. It is because del 2z by del x del y is missing, so its value is equal to 0, and the value of t is the coefficient of this, so it is equal to minus y to the power, it should be n, not 2n. It should be okay, it should be y to the power 2n, not n. So there is a mistake in this question. It should be y to the power 2n. So the value of t is equal to minus y to the power 2n. So again, we'll calculate the value of s square minus 4rt. So that will be simply this expression that can be written as a square of this expression. So it is greater than 0. So we conclude that the given partial differential equation is hyperbolic. And as I told you, in every case, we'll solve this equation. When we put the values of r and s from here to here in this expression, you will get this expression. And when you simply solve this, you will get the value of lambda is equal to this. So accordingly, we solve this equation as we have seen in the last examples also. And when you simply solve this, you will get the value x plus minus y to the power 1 minus n is equal to constant. So one value we can take as a xi, one value we can take as a eta. And again, we'll calculate these values xi, zx, zy, zxx, zyy by finding it's the standard form as I have explained, and by putting the values, you will get this expression. And now we'll put this expression in the given equation. What is the given equation? Our given equation is this. This is our given equation. It should be, as I told, it should be y to the power 2n, not n here. And when we'll put all these values in this expression, and when you simplify, you will have to try yourself. You will get this expression, and from this, it is equal to 0. When you will find the integration with respect to eta, from this you will get z is equal to z xi is equal to some function, you can say, or f1, it is a function of xi. And when you will find its integration with respect to eta, you will find that z is equal to a xi plus b eta, or as here as it is written as a f1 and f2, there is no problem, we can write a or b or f1 f2, and then simply the putting the value of xi and eta over here, you get this expression where f1 or f2 are arbitrary function of their respective arguments. So by this way, this question is also solved. Thank you very much. You can find the link of this ppt in the description. Thank you.